Hey everyone, and welcome back to the channel. Let's begin with a mind-blowing thought experiment. Picture the earliest moments of existence, 13.8 billion years ago. The universe wasn't a vast place. It was an incredibly hot, dense singularity, a point smaller than an atomic nucleus. Then, in a moment of unimaginable energy release, a literal Big Bang, space, time, and matter exploded into being. Out of that primordial chaos, galaxies spiraled, stars ignited, and eventually one specific small blue world was formed, our Earth. We humans emerged from the slow, deliberate process of evolution on this single planet. We are the highest intelligent life here. We've managed to create complex civilizations, compose masterpieces of art and music, and launch devices that have left our solar system. We have achieved incredible things. But when you truly take the time to gaze up at the vast, silent, and endless night sky, do you ever feel that overwhelming, profound sense of smallness? In the eyes of the cosmos, our individual lives, even the entire recorded history of humanity, are nothing more than a momentary, fleeting flash. This perspective naturally forces us to confront an ultimate question, one that we are driven to know, yet often fear the answer to. How much time does humanity, as a species, actually have left? This is not a tale spun from science fiction. It is not a casual doomsday forecast. What we are about to discuss is hard scientific calculation rooted in astrophysics and planetary science. Today, we are initiating an epic, terrifying 6 billion year survival countdown. We will track this timer from the cosmic origin through the inescapable destruction of our home world and finally, to the only viable plan for human survival, interstellar escape. We will face this ultimate existential challenge together. If the sheer scale of the universe and the future of human survival fascinates you, make sure you stay tuned until the very end. We have a lot of complex science to break down. But first, we must start with the most immense perspective of all, the cosmic scale. To successfully calculate how long we have, we must first establish a baseline. How brief our existence has been so far. The accepted age of the universe is a staggering 13.8 billion years. To put this in perspective, imagine we compress this entire cosmic history into a single, manageable hour. On that scale, the dinosaurs went extinct about 10 minutes ago. The entire recorded history of human civilization, from the first written word to now, would only appear in the last fraction of a second of that hour. Now, let's bring that scale closer. The average global human lifespan, according to the World Health Organization, is only about 73.5 years. This is a truly terrifying comparison. Your precious life and mine are less than a speck of dust compared to the universe. We are incredibly fragile and temporary. What about the longevity of the Earth itself? Our home planet formed approximately 4.54 billion years ago. In its long, violent history, the Earth has survived at least 5 major mass extinction events. These were moments where up to 90% of all life was wiped out. Yet, life has always been resilient, adapting, and finding a way to rebound. However, this time, the calculation is fundamentally different. We are calculating the inevitable expiration date of the Earth itself. You might think about immediate threats, nuclear proliferation, catastrophic climate collapse caused by human activity, or a random, civilization-ending asteroid impact. These are indeed risks that could wipe us out tomorrow. But let's take the optimistic view for a moment. If humanity is exceptionally lucky, if we somehow manage to successfully avoid all the immediate self-inflicted and random catastrophes, what is our guaranteed, absolute secure survival time? The answer, incredibly, is outside of our control. This deadline is not set by geopolitics or technology. It is set by the most massive, most stable, and most essential object in our immediate neighborhood, the sun. The fate of Earth is inextricably linked to the life cycle of this single star. It's time to look at the most crucial point in our countdown, the final end of Earth. Think about that scale. Does it make you feel more motivated to act now, or more overwhelmed by our fate? Share your thoughts in the comments below. We need to know what we're up against. The sun is currently classified as a main sequence star. For billions of years, it has maintained a delicate balance, generating light and heat by fusing hydrogen into helium deep within its core. This stable output is what has allowed life to thrive on Earth for so long. But the laws of astrophysics state that all stars must eventually die, and the sun's lifespan is strictly limited. In approximately 5 billion years from now, the hydrogen fuel supply in the sun's core will finally be completely exhausted. When this happens, the fusion process will cease in the core. Without the outward pressure from fusion to counteract gravity, the core will begin to collapse inward, causing the outer layers of the sun to dramatically expand and cool, entering its ferocious red giant phase. As the sun swells into this massive red giant, its surface will become so huge that it will consume Mercury and Venus, and might even extend right out to, or even beyond, Earth's current orbit. Even in the unlikely event that the Earth is not entirely incinerated and absorbed, the red giant sun will be thousands of times brighter and hotter than it is today. Earth's vast oceans will boil away entirely. The atmosphere will be stripped by the intense solar wind, and the surface temperature will soar past the melting point of rock. Earth will be reduced to a barren, molten hellscape. So, the definitive cosmic final countdown for Earth's physical survival is 6 billion years. But hold on. If you think humanity has 6 billion years to leisurely plan its next move, you are fundamentally mistaken. And this is the crucial point. Scientists have calculated that Earth's functional habitable window is far, far shorter than the sun's total life. The stability we rely on is already eroding. Even during the sun's current main sequence phase, its intrinsic luminosity is steadily and slowly increasing. Within the next 1 billion years, the sun's output will increase by an estimated 10%. This seemingly small increase will be enough to trigger a devastating, unstoppable runaway greenhouse effect. This is the point where the planet's natural feedback loops, like the moisture in the atmosphere, will amplify the heating beyond our ability to stop it. Our oceans will evaporate into the atmosphere, creating a thick, dense greenhouse layer. Life as we know it will become impossible. The Earth will permanently transform, becoming an inferno almost identical to conditions on modern-day Venus, and will be completely and permanently unsuitable for any complex life. Therefore, humanity's true existential habitable doomsday countdown is less than 1 billion years. 1 billion years is a number so vast it's difficult for the human mind to process. But let's contextualize it in terms of human generations. Using the average lifespan of 73.5 years, this means we have approximately 13.6 million generations left. These 13.6 million generations must succeed in guaranteeing the continuity of human civilization. If they fail, that's the end. Will we just sit and wait for this inevitable cosmic guillotine? Absolutely not. Throughout history, humanity's defining characteristic has been our refusal to accept a predetermined fate. Before the habitable doomsday arrives, humanity has only one imperative: escape the cradle. If Earth becomes uninhabitable, the only way for the human race to survive and flourish is to transition into a multiplanetary and, eventually, an interstellar civilization. Our comprehensive escape plan must be structured into both short-term and long-term phases. 1. Short-term plan: Mars and lunar colonization. The immediate short-term goal is critical: to establish redundant backups of Earth civilization. The Moon, while close, its lack of atmosphere and severe radiation make it unsuitable for large, self-sustaining cities. However, the Moon is invaluable as a resource hub, a laboratory for off-world living, and an essential interstellar transit station for missions going further out. Mars. This is unequivocally our most promising celestial spare tire. It possesses frozen water ice, moderate gravity, and a solid foundation of landmass. Colonizing Mars serves two vital functions. It immediately backs up human civilization, and it allows us the perfect terraforming technology. This is the process of gradually modifying Mars's atmosphere, temperature, and environment to make it more like a second, living Earth. The difficulty of Mars. The challenge is monumental. How do we create self-sustaining, closed-loop life support systems when resupply is unreliable? How do we build habitats strong enough to counteract the deadly cosmic radiation and frequent dust storms? We are in the early stages of this exploration, but given the acceleration of private and public space efforts, humanity's first permanent off-world migration is a realistic prospect that could very well happen within many of our lifetimes. The Red Planet. our backup, or graveyard. What do you think is the biggest hurdle we need to overcome on Mars? The radiation, the food, or the psychology of isolation? Let me know below. 2. Long-term plan. Breaking the solar system barrier. Even a successful, thriving colony on Mars is not the final answer. It is still vulnerable. It remains within the same solar system. When the red giant phase hits, Mars will also suffer a catastrophic fate. The true, definitive survival of human civilization relies on a quantum leap, interstellar travel. We must unequivocally locate and reach another habitable exoplanet, a true Earth 2.0. The overwhelming challenge: distance. The closest star system to us, Alpha Centauri, is roughly 4.37 light years away. This means that even light takes over 4 years to reach it. At the speed of our fastest spacecraft day, reaching that system would require a journey lasting tens of thousands of years. This unacceptable timeline forces radical thinking. This distance problem leads to 2 primary long-term escape strategies. Generation ships, the most realistic current solution. These will be enormous, multi-generational spacecraft, essentially self-contained mobile cities with closed-loop ecosystems. The people who launch the ship will not be the ones who arrive. Dozens of human generations will live and die aboard the vessel. The sole purpose of every person born on the ship, their life, their work, their entire existence, will be dedicated to ensuring their descendants reach an entirely new, never-before-seen world. The psychological and societal complexities alone are staggering. Hypothetical solutions, warp drive, or hibernation, this is where we cross into science fiction, but it represents the goal. If we could somehow harness physics to achieve near-light speed travel, develop a genuine warp drive to manipulate space-time, or perfect the ability to place humans into ultra-long-term suspended animation, cryosleep, for centuries, then and only then can we effectively conquer the vast distances between galaxies within a meaningful time frame. Here's a deeply personal question. Would you choose to board a generation ship? To dedicate your life and the lives of your children to a single journey with an uncertain destination, all for the sake of humanity's future? Tell me your choice. 3. My estimate and optimism. Looking at all the evidence, I hold a deeply rooted, though cautious, optimism that human civilization will manage to survive past that 1 billion-year habitable deadline. In the immediate future, say, the next 100,000 to 1 million years, humanity faces the highest risk of all, self-extinction. We could fail due to runaway artificial intelligence, engineered plagues, or a final, devastating nuclear exchange. However, if our species can successfully navigate this initial dangerous civilizational risk period and manage to successfully establish self-sustaining multi-planetary colonies, then humanity will have completed the most critical evolutionary transition from a fragile earthbound species to a resilient cosmic species. The fundamental law here is the survival probability of a multi-planetary civilization increases exponentially because disaster on one world will no longer mean the total collapse of the entire species. Backup civilizations on other worlds can guarantee continuity. My bold, perhaps controversial, estimates are humans achieve the first self-sustaining Mars colony within 200 years. 80% the technology is mostly there. The political will is growing. Humans develop viable interstellar sublight speed propulsion technology within 1,000 years. 50%. It depends heavily on fusion and antimatter research. Humans become a distributed multi-galaxy civilization before the 1 billion-year deadline. 40%. A challenging but achievable goal, driven by necessity. We have 13.6 million generations to solve this equation. Just consider the pace of progress. Our Homo sapiens ancestors only left Africa 70,000 years ago. We invented flight and landed on the moon within less than 70 years. We possess an unmatched capacity for learning, creative problem-solving, and ruthless adaptability. The ultimate hope for our species, therefore, doesn't lie in the distant gravitational pull of a new planet. It resides entirely within the incredible complexity of the human mind. The ongoing, exponential progress of technology offers the possibility of solutions that we literally cannot yet anticipate. The boundary of human civilization will cease to be a single blue planet. It will expand and encompass the entire magnificent universe. So, let's bring this epic 6 billion year survival countdown back down to Earth and summarize the essential takeaways. The hard, inescapable deadline. In 6 billion years, the sun expands into a red giant and the Earth is utterly and physically destroyed. The practical, urgent countdown. In less than 1 billion years, Earth's escalating heat will trigger a runaway greenhouse effect, rendering it completely uninhabitable for complex life. Humanity's non-negotiable imperative. Within this 1 billion year window, humanity must complete its evolutionary transformation into a multi-planetary civilization, securing permanent settlements on Mars and the Moon, and ultimately realizing the goal of interstellar travel. The ultimate challenge facing our species is a dramatic race against the constraint of time and the vastness of distance. Contemplating the deep future humanity forces us to see our current challenges with an entirely new, profound perspective. Every major decision we make today, from policy regarding climate change and global stability, to the funding and execution of fundamental scientific research, is not just a temporary measure for our own comfort. It is an investment, a life or death choice, made for the survival rights of the 13.6 million generations that will follow us. And finally, every single constructive idea you propose in the comment section today, every piece of thoughtful debate, contributes to the collective human mind. It could be the very spark of innovative thought that solved the problem for future human civilization. If you found this deep dive into macro-scale survival and hard science compelling, please take a second to smash that like button. It is the single best way to support this kind of content. And if you want to join the most important debate about humanity's future, leave your thoughts in the comments. Do you truly believe humanity can survive the 6 billion year deadline? And if so, how? Don't forget to subscribe to the channel and hit that notification bell so you don't miss our next journey into the ultimate questions of science and survival. Always remember this. Humans are not the eternal prisoners of the Earth. We are the conscious children of the stars. Our destined path is not limited by gravity, but by the magnificent, endless stellar ocean. Thank you for watching, and I'll see you next time.